Hello, this is Robert Washer, and this is my animation skinning demo. First off, I'm going to go through the converter and show you how models are converted. Alright, here's the convert models batch script I have. It basically just has a format of calling the converter on whatever FBX file with the base is going to be whether or not it's skinned, and export it to the file, and then also is the option to add any texture you want to specify. And then after you call the actual converter, we end up wrapping up all the export stuff that converter exported and wrapping that up into individual files with vodka, and then we end up combining all those with the LIU. And that is basically what it's doing for each one. Here we're doing the humanoid, here we're doing the teddy, and then here we're doing the dude FBX files. So let's show this going converted. First I'm going to clean out the folder of all the extra stuff that's generated, and then I'll start running it. And now we are we're exporting the humanoid data to it, the custom ROB files, then we did the teddy, and now we're exporting the dude file. Run for a couple seconds. Yeah. And it is finally done. And as you can see, we now have the 3 ROB files, one for teddy, one for humanoid, and one for dude, as well as the text file that was made. So I'm going to go copy these over to the viewer, which just sends it over to the game engines folder, so that the new that was just made is now being used in the engine. And then I'm going to go through some of the code in the converter, showing the main work I did for getting the skinning data exported. Alright, so basically in this display link class is where I did most of the work. Basically here I'm basically setting up a vector of vectors that hold weighted links, which is basically just a weight and then the index of what bone link we are doing, and this the vector of vectors, it basically maps to it's the same size as the vert vector that is generated in the mesh exporter part. And also here we are getting a bone trans data vector, which is basically the same size as the hierarchy data, which is going to hold the bind pose for each bone. And I'm just setting this all to basically a node transformation matrix data to start with, and then later on I will overwrite the ones that actually have that are actually used with the skinning data, because some stuff like the dummy nodes and some of the roll nodes don't really affect any of the skinning, so they don't actually need that data, but we're setting it to 0 so that it doesn't affect it adversely either. And basically I'm going through each of the skins, going through each cluster, and then I'm getting the link name from the cluster, as long as the link is not null. And then basically I'm going through and going through the hierarchy structure that I made in display hierarchy, and basically finding where the higher index, which name matches the link name that we just got from the link, so that way we can get the bone index in a hierarchy of the bone that we're currently working on. And then we go through each of the control point indices and find each vertex that this bone influences, and the weight of it, and then basically from that I'm sending for each control point. We're basically adding in for that control point index into my weighted link structure the new weight link, which is basically has the bone index -1, because in my game engine I shift each bone to the left one, so I have to make it consistent with, I export it consistent with the engine, which is why it's subtracting 1, and then it also gives the weight of that bone. And it just keeps going through all of these, and then for each bone bone that affects the skinning, we calculate the transform, which is basically the inverse of the transform matrix times the transform link matrix, and that basically is getting all the data from that matrix that we just calculated and sending that in the bind pose. Also subtracting 1 to make it consistent with my game engine. So then that went through all the vertices of each bone and getting it into the opposite format of, for each vertex, these are the bones and their weights for that vertex. So then after we have it in that format, we end up zipping that up with the slimvert structure that was created in the mesh export. And in this process we also is where I also end up reducing the number of bones and weights to 4, and basically just by replacing the lowest weight, so it's only the four highest weighted bones get kept. They are added into a new structure of skinning verge, which is basically just another vector of vert skinnings, which is basically just a basic vert with the position and normal data, and then also the weight and bone data. So after that, basically, this is basically just combining the two structures and then reducing the number of bones, and then I go through the vector, each vertex in the vector again, and I renormalize the weights so that everything is, for every vertex the bone weights always add up to 1. And that is basically most of the work done. And then in the main I also have just a couple things just to make, so basically if you're skinning you're gonna have to export data a little differently than if you don't have skinning data, so that I basically just have 2 different ways to export the data depending on whether you have this stuff, whether the model has skin data or not. And then over in the game engine, I basically, the work I did mainly, I added a whole bunch of shaders, which are all in the skin shaders. I added a ambient diffuse specular multi-light skin shader. I added a single light shader, just a base shader, a texture shader. Basically all of them have the same structure as far as calculating the actual skinning calculation, running the actual skinning calculation, which is basically always to calculate the position you're is basically just accumulating basically multiplying the bone transformation times the vertice, and weighting that outcome, and then adding it up for all the weights of that given vertex. And these weights are passed in shaded as an attribute, as well as the bone indices for that actual vertex. And for the normals, it's the same calculation, except you're taking the inverse transpose of the bone transform instead of just the bone transform itself. And basically, as far as a lot of the work I did was ended up being in my animatable game object class. I basically added in a series of bind pose matrix that hold the exported bind pose, and also holds set of the bone matrices of that basically hold the current bone transform as far as where it is in the animation. And that is used basically so that in the update it basically here it is. It basically multiplies the inverse of the bind pose times the bone matrix, the bone transform matrix, and passes that to the graphics object, which is always going to be a graphics object skin, which is basically the graphics object that is the base of all the skinning graphics objects that I have, because I have one for each type of shader. And it basically, the skin one basically has just the functionality to set and update the bone structure so that they can be used when passing the data over to the shaders. And then, so as you can see in here, we'll always, is basically the same for everyone, you're always passing the bone transforms over to the matrix in the same way as this. It's basically just looking through all the the number of bones and just passing it in for that specific entry, passing in that value. And as far as loading in all this data for the skinning, you have in the loader, we have this FBX loader load skin complex, which is where most of the loading gets done. It goes through, it loads the package header, it loads model info, loads the VBO, which now has the final skin structure, which is the large vert structure that has the position, the UV, the normal, the weight, the bone weights, and the bone indices themselves. And in the basically sends it over to this model manager, which will end up creating a model, and in the model is where I pass that bone index data to the GPU file, basically using that new stride and the new amount of data. And that's for the most part the majority of the work. I also did broke out the animation to an animation instance so that I can have multiple instances of the same animation running at the same time. So let's fire this up, and I'll start showing you. Here I have 5 different game objects. 3 of them are the humanoid, 1 is the dude, and 1 is the teddy model. Let's see if we go to the first one. This is a humanoid that's basically using a multi-light ambient diffuse specular shader, and it is currently doing the shot animation. As you can see, I can pause the animation, I can play it again, I can speed it up, I can slow it down, I can change animations to do whatever I want, and can keep going through that. Then we'll go to the next one, which is a wireframe shader, so you can see that you can show the actual bones that I have, or I can also disable the bones as this is shown. I can disable, I can re-enable the bones, and basically like the other way I can also pause that, and I can change the animations on each of these. Go to this one. This is also a multi-light shader, and then you can also pause, play all these animations. And we'll go over to the dude, which is right there, and he's just in a single light ambient diffuse specular shader. with a white light basically. And like the rest, we can pause, play, slow him down, speed him up. And then last but not least, we have the Teddy, which is just a textured, skinned model with just a simple texture without any actual lighting. And like always, we can make him go to his idle pose, go back to walking, pause, play, slow him down. And that is basically the animation skinning demo for my animation skinning work. Thank you.